Hello all, welcome back to Project Mastery Podcast. We will be covering Phase 3 of CPMAI project in today's episode. Phase 3 is all about data preparation. During this phase of data preparation, we will be focusing on the activities that are required to construct the dataset, and this dataset is going to be used for modeling operations. Data preparation activities will include data cleansing, it will include data aggregation, it also includes data augmentation, data labeling, data transformation, data normalization, and will include any other activity for data which is of structured type or unstructured type or semi-structured type. What do we mean by data cleansing? What do we need to do so that our data is well prepared for machine learning project? What are the V's that we should be worried about when it comes to data cleansing? How are you going to deal with data that is missing? How are you going to deal with data that is incorrect? What are the source of data that we can use to validate whether the current data is okay? Or if you want to enhance the current data, what is the additional source of data that we can use to validate? When we talk about data augmentation, we need to understand what are the data labeling needs. How are these needs going to be met? Is there a possibility to scale the project based on the data labeling requirements, based on the time and cost involved? What is the data or the additional metadata that we require to augment the data so that it is valuable for learning? What are the approaches that you will have to take? Do you need to take a sampling approach, or you need to select a subset of data from a large dataset? What are the additional enhancements, requirements that needs to be made to the data so that you can add more value for the model? These are the questions that you need to think from a data augmentation perspective. We then focus on data engineering concept. When we talk about data engineering, you need to think how are you going to implement the data preparation pipelines? How are the data labeling requirements going to be met from the perspective of data engineering? What are the technical challenges that you're going to face when you're going to integrate data from internal sources as well as external sources? Who is going to manage, how are you going to manage the training data pipelines over a period of time? We all know that pipelines are model need specific, they are also pattern specific. We should identify the specific requirements for data preparation based on the specific requirements for model operationalization and also based on specific requirements for model training. We need to build pipelines before we start training the model. We should not be passing phase 3 until data preparation pipelines are defined. We also need to manage the requirements for data privacy and the requirements for data security. There's a need to consider data privacy laws compliance. There's a need to anonymize data. There should be a method in place to store the minimum amount required to get data related to training. You need to protect the data that is being stored. There's a need to secure the machine learning models to avoid tampering. There's a need to secure the model metadata, configuration and settings. Hence, it's important that you meet the requirements for data privacy and security. You can use generative AI and LLMs for data preparation. LLMs are able to summarize, LLMs are able to enhance or prepare data. Foundation models are always good at spotting trends, they are good at spotting patterns. Foundation models can fill in the data that is missing based on whatever data the model has been trained on or based on the context window. You should always be aware of data manipulations and hallucinations that happen during this activity. When we talk about supervised learning, machine is going to learn a particular pattern which correlates to the data to the label. Supervised learning will require a lot of examples of specific labels for data which is of a particular type. You need to determine what labels to apply, and there is a lot of effort required to apply it. The labels are going to represent the predictions that you want the machine learning model to make based on the input data. Labels could be dog for images or portion of image that is going to represent a dog. In data labeling, we are going to add labels to raw data such as text, videos, audios, images. Label is something what is being learned. There is a labeling process here. We are going to gather the sufficient quantity of data which is going to be the representative data for training. Hence you do the data collection first. Then you are going to determine which data labels to apply. You need to provide a meaningful context without too many dimensions. You need to keep tags to a minimum or keep tags to a maximum of 10. You need to have a human in loop in place, HITL, which stands for human in the loop. Humans are required for annotation. Humans are required to verify machine-based annotations. Quality assurance needs to be completed. You have to verify the accuracy of labels. You have to verify the accuracy of annotations. Train and test is an important activity. You're going to test the model on a data which is unlabeled, and you're going to check the predictions within a required threshold, which is a confidence threshold or accuracy level. There are various QA algorithms available, such as consensus algorithm. You can make use of these algorithms while you perform quality assurance for the labels. You can use GenAI to automatically label the data or pre-label the data. there are different approaches available like self-supervised approach and semi-supervised approach. Using algorithmic approach such as self-supervised approach, which is going to work on large dataset which is unlabeled for a broad set of tasks. Foundation models are built using this approach. When you talk about semi-supervised approach, it is going to use a combination of the limited amount of labeled data for supervised learning. Then it is going to use the approach related to unsupervised learning to automatically learn the label based on the previously labeled data. To summarize, you can use these approaches to reduce the labeling requirements. Before you move on to the next phase, you need to understand that have you adequately determined the data preparation requirements and what are the actions taken. Do you have a response for all the questions that we spoke now for phase 3? Do you have the answer for all of the critical questions for every different concept that we spoke now? Let's say that there's a practical project that you have been assigned now, and what are the tasks that you will perform when it comes to data preparation phase? You're going to select the data, identify the rationale for inclusion of the data, identify the rationale for exclusion of the data. You then go to clean the data, where you deal with data cleaning report, construct data based on attributes. You then go to label the data, where we spoke about the data labeling requirements. You're going to integrate the data, where data merging happens, data augmentation happens. You will then format the data. Data anonymization comes into picture, data normalization, data denoising, reformatting of data, all are covered under format data. Finally, you're going to describe the dataset. Dataset description is an important task that happens. Let's get into details. You're going to select the data as first task. During data selection, you're going to decide on the data which is going to be used for your analysis. You're going to list the source of data to be selected, or you're going to document what are the selections that have been made for data. List the data that is to be included. You're going to list the data that is to be excluded and the reasons for these decisions, which means you're going to describe the data that's been selected and you're going to give a rationale for inclusion and exclusion. You're going to create a reusable data pipeline so that you're able to collect the data, ingest the data, prepare the data for training purpose. You're going to create a reusable data pipeline that would be similarly used for data which is related to real world inference. You're going to describe what actions and decisions that you have taken to fix the data quality issues related to verified data quality task, which we spoke earlier on data understanding phase. Data transformations for cleaning purpose and what is going to be the possible impact on the results should be considered. Reordering of attributes is an important activity that will happen here. Some tools have requirements on the attribute order. For example, first field needs to be unique identifier for each record, or the last field should be the outcome field the model is going to predict. Reordering of records will also happen. You might need to change the order of the records in the dataset. Perhaps the tool may need the records to be sorted according to the value of the attribute which is an outcome. Sometimes modeling algorithm might require the attributes to be in a fairly random order. For example, in case of neural networks, it is best for the records to be presented in an order which is basically a random order, although there are tools that can handle automatically without explicit intervention from the user. Deduplication is another activity. Some model operations will require the removal of records or rows which are duplicate. You need to list the actions taken to identify the duplicates. You need to list the actions taken to eliminate the duplicates. Erroneous field data might be placed in incorrect fields, so you need to document the steps that are required to identify the incorrect fields and what methods you're going to use to fix the erroneous data. Syntax changes. There are syntactic changes made to satisfy the needs of the specific modeling tool. Example, there's a need to remove commas within the text field in a comma delimited dataset file, or you need to trim the values to a maximum of 10 characters. Normalization is required, where you want to change the value of numeric field to be within a predefined range for performing certain operations related to model. Instead of having a price range of arbitrary value, probably you can give it a scale between 0 to 1 with intermediate values getting calculated beginning with 0 and the maximum value of the data field. Denoising. There is a possibility the data may be erroneous or spurious due to the way the data is being collected. Some pre-processing might be required to remove the spurious data or the noise from the results. Once you remove the noise, then you feed them into model operations. Anonymization. We are collecting data from various sources which will contain personally identifiable information. There are regulatory, privacy, security reasons. If there is a need for anonymization, it has to be identified well in advance, and you should document the methods which are going to be used for anonymization and verification. Anonymization should not negatively impact the performance of resulting models. We then go ahead and enhance and augment the data. In this particular task, you may come up with derived attributes, or you're going to transform the values for the existing attributes. These methods combine the information from multiple records or from multiple tables to create new values or new records. Derived attributes are new ones that are constructed from one or more existing attributes, part of the same record. Example, length multiplied by width is equal to area. Generated records, you're going to describe the creation of completely new records. Example, you want to create a record for a customer who has not made any purchase in the last 2 years. There's no reason to have such records present in the raw dataset, but for modeling purpose, it may make sense to explicitly have them represented so that you are proving that there are customers who made 0 purchases in the last 2 years. Enhancement from additional sources, you're going to merge the data, you're going to join the data from different sources. That is going to have different information. You're going to perform data augmentation and enhancement operations. You're going to document the methods used for augmentation, document what are the additions that have been made to the data pipeline for augmentation, document what are the modifications made to data pipeline for augmentation. You're then going to label the data. You're going to identify the methods for data labeling. You're going to get yourself engaged in data labeling efforts. List out what are the specific data labeling needs and the annotation needs. Identify the methods to be used for data labeling, including the use of third-party label, pre-existing label data, or mixed approach. What is going to be the cost for data labeling? Identify the method for verifying the data labeling quality. You're going to conduct data labeling activity and report on data labeling outcomes. Perform data labeling to the extent it is required for data. You would have detailed the method and the approach used. You need to document the additions made to the data pipeline for data labeling. You need to document the modifications made to the data pipeline for data labeling. You have covered all the concepts related to data preparation phase. You have understood that data preparation phase is the phase which is going to focus on all the activities required to construct the dataset, which is going to be used for modeling operations. We spoke about data cleansing, data aggregation, data augmentation, data labeling, data normalization, data transformation, and every other activity that will be performing with the data, whether it's going to be structured, unstructured, semi-structured, we're going to perform these activities. We have come to the end of the podcast. Hope the knowledge is valuable. Thank you for tuning in.